Hey kiddos, these are the last two quick topics in this unit. They will be on your test next week, and then we're done with Unit 8. So for those of you who are just here for a formula, pause, write all these down, and go about your merry way. If you want some explanation on them, then stay tuned. I'm still going to make it quick, but this is everything in the video. All of these equations are formulas. All right, I'm going to start with average value. So this is its average value of a function. So what this does is exactly what you think it should do. It's going to find the average y value over a certain domain in your function. So to find an average, we add up all of the y values, and then we divide by how many there are. That's what this 1 over b minus a does. So of all of the formulas on this page, I hope this is the most intuitive to you. So 1 over b minus a, integral from a to b of f of x. So these questions can be asked only in one certain way. It's going to sound different. So they can ask you to find the average value of, and they'll give you some function, and it'll probably be exciting. Obviously, that's not. And then they have to give you the bounds too. So if I did like from 1 to 6, then all I have to set up, this is a, this is b, and this is my function f of x. So I'm either setting up or I'm actually evaluating. It just depends. This would be 1 over b minus a times the integral from 1 to 6 of x squared dx. And it's that quick. So the way they make these sound different than they are is they make f of x stand for something. So they could say find the average velocity of, and then instead of calling this f of x, they would call it v of t or something terrible, so scary. And the setup would be identical. Or they could find the average number of turtles, and this is actually a function of turtles. It can be anything, so they can make it sound different. But if they're asking you to find the average value of something, you're going to use the average value formula. Okay, on this side are all of the different ways to do arc length. And the reason that there are 3 is because sometimes you're working with respect to x, with respect to y, and then this one's your parametric. Let's take a second and look at this. Look at it, stare at it for 5 seconds. 4, 3, 2, 1. Yep, it's familiar to you, isn't it? I hope so. It better be. I even circled it in purple because it's on your purple sheet. This is the exact same formula as you would use for distance traveled. Well, does it make sense to you that the length of an arc and the distance you travel would have the exact same formula? You're nodding yes. I know you are. So yeah, those are identical, which is why it's in this unit. So these, let's talk about where all of these come from. So if I have a squiggle wiggle, I'm going to call it f of x, and I want to find the length of that squiggle wiggle. What we're doing is we're zooming in really close, and we are going to draw some triangles. And we're going to give them heights of dy, and we're going to give them lengths there of dx. I'm talking like they're rectangles, they're triangles. But what we're doing is we're finding hypotenuses. And the length of this hypotenuse would be the square root of dy squared plus dx squared. Great, wonderful. So we have these little changes in y, these little changes in x's, and they're teeny tiny, right? So that we can be infinitesimally small. The thing is that doesn't make sense. So we have to manipulate it a little bit. And also we have to add up all of them. So we add up all of them with a super fun integral. And then somebody, hopefully at home, is screaming, you need something on the end of your integral like, oh, I don't know, a dx. But you can't just go around multiplying dx because it makes your integral work. You also have to divide this thing by dx. So what we end up doing is we have our integral. I'm going to put the dx inside the radical with everything else. So there's dy squared plus dx squared all over dx squared because it's squared square rooted, so I haven't changed it. And then it's just a quick clean up. So then it's the integral. We all know that you can put those together and put those together. So it's the square root of dx over dx squared is 1 plus dy dx squared times dx. The end. Because the dy1 has the exact same manipulation. You would just be dividing. You would do this by a dy instead. And then the same thing, this would be a dy squared down here. And it has the same manipulation. So there are two versions. I mean, I know there's three, but there's two function versions because you have to take a derivative inside here. So I have to differentiate with respect to y, whatever my function is, or I have to differentiate with respect to x, whichever my function is. It just depends. And we know how to differentiate anything. Like there's rules for everything to take a derivative of. But inside here, you're then going to square it, add 1, and square root, and that can make the integral really complicated. So there are two versions because sometimes one is easier to, or is possible to integrate when another one's not. So know them, know all three of them. This is hopefully the one you're most familiar with, and then those two are not a big stretch. Okay, when you get into your delta is only practice on average value. That's why I talked about it first. I should have said that earlier. You're going to find arc length practice in your test review that will be linked in OneNote shortly. All right, let me know if you need anything.